right, so in a quadrilateral ABCD, assume that the measure of angle A is equal to 90, which is equal to the measure of angle C. We're going to draw diagonals AC and BD and show that angle DAC is congruent to angle DBC. All right, so let's go ahead and start this proof. So first off, I know this is a quadrilateral, so ABCD is a quadrilateral. And this implies that the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D is equal to 360. Now, I already know that angle A plus angle A is 90 and angle C is 90, right? So this implies that 90 plus the measure of angle B plus 90 plus the measure of angle D is equal to 360. If I subtract, so 90 plus 90 is 180, of course. If I subtract 180 from both sides, I get that the measure of angle B plus the measure of angle D is equal to 180. Now, I have the sum of the opposite angles of a quadrilateral are both 180, right? So I have the measure of angle A plus the measure of angle C is 180, and the measure of angle B plus the measure of angle D is equal to 180. So by the inscribed quadrilateral theorem, I know that ABCD is cyclic, right? That means I can inscribe a circle about ABCD. All right, so there's my circle, right? ABCD is cyclic. So now this implies that the measure of angle, so DAC, right? DAC is equal to half the measure, because of the, of course, inscribed angle theorem, because, of course, this is now an inscribed angle, right? This DAC. So by the inscribed angle theorem, I know the measure of DAC is equal to half of DC, right? Half the measure of arc DC. And I know that DBC is equal to half the arc of DC, right? Which is equal to the measure of angle DBC. So this implies the measure of angle DAC is equal to the measure of angle DBC, which of course means that angle DAC is congruent to angle DBC. And that is our proof for this problem.